Hello dear students, welcome to Teja my YouTube channel. So in this session I am going to discuss about the list of formulae from the chapter that is electric charges of fields. Shall we start? Yes. So first one we have, that is from quantization of charge. Quantization of charge, we have Q is equal to plus or minus NE. Q is equal to plus or minus NE, where N is an integer, and E is basic charge, that is 1.6 into 10 to the power minus 19 Coulomb. Okay, that is the first formula. Second formula is Coulomb force. So Coulomb force between two charges is given by F is equal to 1 over 4 pi epsilon naught Q1 Q2 divided by R square. So if you consider vacuum, this is the formula, but if dielectric medium is given, you have to write K. So this is the formula for Coulomb force. And what is the value of K? So K value is equal to 1 for air or vacuum. Okay, for air or vacuum, K value is 1, and K value is infinity for conductors, metals or conductors, and K value lies between 1 and infinity, that is K value is greater than 1, less than infinity for dielectric materials, dielectrics. So this is the Coulomb force. Then what is the formula for dielectric constant? This is K value, dielectric constant, that is represented by K, or it can also be termed as relative permeability, relative permittivity, that is epsilon r. Permeability comes in magnetic field, here it is electric field permittivity. So that is given by K is equal to epsilon r, can be written as epsilon divided by epsilon naught. This is permittivity of a medium divided by permittivity of free space. Also in terms of Coulomb force, so F divided by F naught divided by Fm. This is the electrostatic force in vacuum divided by electrostatic force in given medium. This is the formula. Okay. Next, fourth one we have charging by conduction. Charge conduction between two similar bodies. For example, I have let me consider here, there is a sphere here and there is one more sphere here. Charge on this one is Q1, charge on this one is Q2. When they are allowed to touch each other through a contact material or a metal, what happens? Charge from this one and this one, they get distributed. So the final charge will be how much? The final charge is given by Q is equal to Q1 plus Q2 divided by 2. Okay. But sir, what if they are not similar spheres? if one is bigger sphere, one is smaller sphere, then the charge distribution occurs until their potentials become same. That we will discuss in electric potential and capacitance. So this is the formula. Q is equal to Q1 plus Q2 divided by 2. Next, fifth one, electric field. Electric field. What is the formula for electric field? It is E is equal to force per unit charge. Force per unit charge. Next, sixth one, electric field due to point charge. Electric field due to point charge. So what is the formula? E is equal to 1 over 4 pi epsilon naught Q divided by R square. What is the value of 1 by 4 pi epsilon naught? 1 divided by 4 pi epsilon naught. Its value is 9 into 10 to the power 9. So it is given in terms of force. If you want to calculate, it is Newton meter square per Coulomb square. Newton meter square per Coulomb square is the unit for 1 by 4 pi epsilon naught, and 9 into 10 to the power 9 is in SI unit. But if you write it in CGS unit, its value is 1. Okay, in CGS unit. Next, we have electric flux. Electric flux is given by phi is equal to E into A into cos theta. Okay, or in dot product, phi is given by E dot A. Sir, what if very small area is there, and how do you calculate flux? That is given by d phi is equal to E dot dA, differential form. Sir, what about integral form? Phi is equal to E dot dA. E dot dA. Or phi is equal to E dot dA. What is the difference between these two? Here we have closed surface, here we have open surface. This is for extended surface or open surface. Extended surface. This is for open surface. There is one more formula for electric flux that is very important. That is given by Q by epsilon naught, or Q enclosed by epsilon naught. This is called Gauss law in electrostatics. This is called GAUSS. Apostrophe base also you can write. This is Gauss law in electrostatics. Okay. So this is about electric flux. So you can pause the video and write down. I will erase this and write remaining formulae. Okay. Is it clear? Yes. Yes. Next we have what is that? Dipole concept. Okay, dipole concept. In dipole we have first formula. We'll write it as A. That is, electric field due to dipole along its axis is given by E axis is equal to, in vector form also I can write 1 over 4 pi epsilon naught 2 pr divided by r square minus a square whole square. The simplified one is if r is so much greater than a, E axis is given by 1 over 4 pi epsilon naught. So 2p by r cube, 2p by r cube. Okay. Next, second one, E equatorial minus 1 over 4 pi epsilon naught p divided by r square plus a square power 3 by 2. Okay. So if r is so much greater than a, E equatorial is given by minus 1 over 4 pi epsilon naught just p divided by r cube. So if we compare these two, we have 1 by 4 epsilon naught, 1 by 4 epsilon naught, p by r cube, p by r cube. What is the difference here? 2 is there, here minus is there. Therefore, E axis can be written as 2 times E equatorial. This is very, very important for 1 mark. Sir, in a vector form we have minus sign. Yes, E axis is minus 2 times E equatorial. Minus 2 times E equatorial. Okay. This is electric field along the axis and equatorial. We have random point also, like electric field due to dipole at any general point. That is important for KCET. Here I am giving the list of formulae for board exam only. Then C. Okay. That is torque acting on a dipole. Torque acting on dipole in uniform electric field. What is the formula? That is tau is equal to P sin theta. Or tau is equal to P cross E. Tau is equal to P cross E. So this is about dipole. I think axis, equatorial, this is one more is there, that is potential energy. We'll discuss about that in the electric potential capacitance chapter. Okay, dipole is done. One more is there. Yeah, what about dipole moment, where P is called dipole moment, right? Dipole moment, small p is given by, P is equal to 2aq. P is equal to 2aq, or P is equal to 2aq also, where 2a is called dipole length and q is magnitude of any one of the charges. Clear? Yes. We'll move to the next one, that is continuous charge distribution. Continuous charge distribution. In that we have 3 types. One is lambda is equal to charge by length. Second one is sigma is equal to charge by area. Third one is rho is equal to charge by volume. This is called linear charge density. This is surface charge density, and this is volume charge density. Volume charge density. Okay, this is about this. Now we have one more concept, that is applications of Gauss law. If it is done, I will move on to that. Okay, pause the video and write down. Yes, moving on to last one. that is applications of Gauss law. In that we have first one, it is electric field due to uniformly charged infinite straight wire. Okay, electric field due to infinite line charge. In short, I will write that is given by E is equal to lambda divided by 2 pi epsilon naught into R, okay, where electric field is inversely proportional to R. Do remember that. Next, B, electric field due to uniformly charged infinite plane sheet. Electric field due to infinite charged plane sheet, uniformly charged plane sheet. So for that, electric field formula is sigma divided by 2 epsilon naught. C, electric field due to charged, uniformly charged conducting sphere. In conducting sphere we have three cases. One is outside the sphere, that is R is greater than capital R, outside the sphere. Second one, R is equal to R on the sphere, just outside the sphere or on the sphere. C, R is less than capital R, it is inside the sphere. Inside the sphere. So outside the sphere, E is given by 1 over 4 pi epsilon naught q divided by r square. On the sphere, sigma by epsilon naught. Inside the sphere, E is equal to 0. Okay, like this. So in this chapter we have discussed about Coulomb force, methods of charging a body, basic properties of charges. Then we have electric field concept, and we derive electric field formulae for 5 different cases along the axis of the dipole, along the equatorial, then applications of Gauss law. Okay, these three comes under applications of Gauss law. Then we have what is that, dipole concept, electric flux concept, all those things. So if you have missed any formulae, please let me know in the comment section. In the next video, I will try to cover up all those concepts. Okay, keep learning, keep growing. Thank you.